So now we have discussed about fractions and decimals. Now let's discuss about rational numbers. What are rational numbers? The numbers which are in the form of p by q, where q is not equal to 0, are called rational numbers. See, rational numbers. Rational numbers. As I told you, the numbers which are in the form of p by q. Here p by q. P by q means in the fraction form, where q should be not equal to 0. Q should be not equal to 0. So the numbers which are in the form of p by q, where q is not equal to 0, are called rational numbers. Okay, here let's see 2 by 4. Here 2 by 4 is a rational number. It is in the form of p by q. P by q. So this is a rational number. If we take 2 by 0, here this is not a rational number. See, it is in the form of p by q. See, p is 2, q is 0. This is in the form of p by q. But what is the condition here? Q should be not equal to 0. Here q is 0. So this is not a rational number. Now let's take some rational numbers. 1 by 2, 2 by 4, 3 by 6, 4 by 8. See, these all are rational numbers which are in the form of p by q, and in each number q is not equal to 0. So these are rational numbers. Now here see, if you observe, here first one is 1 by 2. In second number, if we simplify, 2 1s are 2, 2 2s are 4. Here the second number is 1 by 2. Here 3 1s are 3, 3 2s are 6, 1 by 2. 4 1s are 4, 4 2s are 8. Here also 1 by 2. Here after simplifying, there is a common answer which is 1 by 2. So this kind of numbers are called equivalent rational numbers. See, 1 by 2, 2 by 4, 3 by 6, 4 by 8. On simplifying this, we are getting the same answer, which is 1 by 2. So these numbers are called equivalent rational numbers. Equivalent rational numbers. See, we have came to know what are rational numbers and what are equivalent rational numbers. Now let's see how to compare two rational numbers. Now let's see comparison of two rational numbers. Comparison of two rational numbers. See, let's take two rational numbers, 1 by 2 and 1 by 3, or 1 by 2 and 2 by 3. Here one number is 1 by 2 and the other number is 2 by 3. See, we have to compare these numbers, means we have to check which one is greater. See, 1 by 2. Let's write some equivalent rational numbers to this. See, we write the equivalent rational numbers. We multiply numerator and denominator with 2. See, 1 into 2 is 2. 2 into 2 is 4. Okay? Comma. Now, one equivalent rational number is formed. Now, we write the other. In this, we have multiplied numerator and denominator with 2. Now, let's multiply with 3. 1 into 3 is 3. 2 into 3 is 6. Now 2. After 3. Now 4. 1 into 4 is 4. 2 into 4 is 8. By multiplying numerator and denominator with same number, then the result will be equivalent to the given number. See, here this continues. Now let's take 2 by 3. 2 by 3. Here let's multiply numerator and denominator first with 2. So 2 into 2 is 4. 3 into 2 is 6. Okay. Here next 3. So 2 into 3 is 6. 3 into 3 is 9. And so on. See, here we have written equivalent rational numbers for 1 by 2 and 2 by 3. Now here we have to compare the two numbers. So here equivalent rational numbers. For comparing the fractions, the denominators should be same. We already discussed in fractions. So here let's check for the denominators in both the equivalent fractions. Here 4, 6, 8. Here 6, 9. So here 6 and 6 are common. So 3 by 6 and 4 by 6. Here 3 by 6. Here 3 by 6 is equivalent to 1 by 2. 4 by 6 is equivalent to 2 by 3. So here denominators are same. So we compare the numerator. So 3 and 4. 4 is the greater. So 3 by 6 is less than 4 by 6. What is 3 by 6? Is 1 by 2. What is 4 by 6? 2 by 3. So 4 by 6 is greater means 1 by 2 is less than 2 by 3. See how to compare two rational numbers? First, we have to write the equivalent rational numbers to the given numbers, and we have to check for the same denominator. And if the denominator is same, then we have to check the numerators. The greater numerator will be the greater one. So by this, we can compare the two rational numbers. What we have discussed, what are rational numbers and what are equivalent rational numbers, and how to compare two rational numbers. Now let's move to the exercise. Now in the exercise 7, first problem, write any three equivalent rational numbers to each of the following. Here he gave two rational numbers and we have to write the three equivalent rational numbers. What are equivalent rational numbers? On simplification, we should get the same number. So we have to write three rational numbers. First one, let's multiply with 2 numerator and denominator. So 2 into 2 is 4, 3 into 2 is 6. And now let's multiply numerator and denominator with 3. 2 into 3 is 6, 3 into 3 is 9, 6 by 9. Now numerator and denominator with 4. 2 4s are 8, 3 4s are 12. See, these are the three equivalent rational numbers for 2 by 3. Now let's come for minus 3 by 8. 1, 2, 3. Let's multiply numerator and denominator with 2 first. So minus 3 2s are 6, 8 2s are 16. Now second one, multiply numerator and denominator with 3. 3 3s are 9, 24. Now let's multiply numerator and denominator with 4. 3 4s are 12, 8 4s are 32. These are the three equivalent rational numbers for minus 3 by 8. See, here we have minus, so we have included minus to each equivalent rational number. So this is the solution for the first one. Now let's move to the second problem. What is equivalent rational number for minus 15 by 36 with first one denominator as 12, numerator as minus 15. In first condition, the numerator should be 12. So here let's minus 15 by 36. Here this should be equivalent to this number. So here let's divide it with 3. 3 1s are, 3 2s are. So 3 2s are 36, 3 5s are 15. Here denominator is 12. And what is the numerator? Numerator is minus 5. So the equivalent rational number for minus 15 by 36 with denominator 12 is minus 5 by 12. And the numerator is minus 75. Means minus 75. Numerator should be minus 75. Here the given number is minus 15 by 36. On multiplying numerator and denominator with 5, 15 5s are 75. Minus 75 by 36 into 5. 36 into 5. 6 5s are 30. 5 3s are 15. 16, 17, 18. 180. So here the number is minus 75 by 180. So here numerator is minus 75. So the denominator is 180. So these are the answers. Now let's move to the third problem. Mark the following rational numbers on the number line. Here he gave some rational numbers and we want to mark the rational numbers on the number line. See, first 1 by 2. 1 by 2 means 2 dividing 1. See, not possible. So we use point. Here 0. 2 5s are 10. Remainder is 0. The answer is 0.5. 0.5 lies between 0 to 1. How? Here. Here 1 by 2. 3 by 4 means 4, 3. 4 dividing 3 is not possible. So we use point 0. Now 30. 4 7s are 28. Remainder 2. And 0.0. So 4 5s are 20. The remainder is 0. The answer is 0.75. 0.75 means it lies between 0 to 1. Here 3 by. Now let's see the third one. 3 by 2. 2 3. 2 1s are 2. 1.0. 2 5s are 10. Remainder is 0. See, the answer is 1.5. 1.5 lies between 1 to 2 middle. So here 3 by 2. Now last one 10 by 3. 10 by 3. 3 10. 3 3s are 9. Remainder is 1.0. 3 3s are 9. 1, 0, 3 3s are 9. This remainder is 1. This process is going to continue. So here 0.33. 3.33 means it lies between 3 and 4 here. 3 and 4 here. Between 3 and 4, 3.33. So let's take here 10 by 3. See here the given rational numbers are represented or marked on the number line. This is the solution. So note it down. Now we move to the third problem, which is last problem of exercise 7. Find whether the following statements are true or false. See here gave some statements and we have to check whether it is true or false. First one, every integer is a rational number and vice versa. See every integer, let's take -3 is a rational number, means denominator 1. Vice versa means reverse the integer is also rational number. He is saying that every integer and reverse of the integer also a rational number. Here -3 is rational number and -1/3 is also rational number. See, while coming to 0/1 it is a rational number and vice versa means reverse of it, 1/0. Here it is not defined, so it is what is rational number? It should be p by q form and q should not be equal to 0. Here 0 is a rational number and reverse of it is 1/0, which is in the form of p by q, where q is equal to 0. So it is not a rational number. So this is false. Okay, in a rational number of the form p by q must be a non-zero integer. As I told you, the numbers which are in the form of p by q where q is not equal to 0 is called rational number. Here p by q and q must be a non-zero integer means q is not equal to 0. So this is true. Here every decimal number can be represented as a rational number. See, let's take 0.10011111 here, so on. Here this is a decimal number where the decimal digits are non-terminating and non-recurring. Means non-terminating means there is no end for the calculation and non-recurring means there is no set of digits which are reoccurring. If we take 3.333 so on, here this is non-terminating but 3 is recurring. In every for next step this is 3 is repeating. Here no set of digits are repeating, 10011011. So this can't be represented as a rational number. So this is false. This is a rational number and it can't be represented as rational number. So false. This is a decimal number and can't be represented as rational number. So this is false. 5/7, 6/7, 7/7 are equivalent rational numbers. See here decimals are same, 777. While coming to the numerator, here denominators are same, 777. Denominators are same. While coming to the numerators, 5, 6, 7, these are not same. So these are not equivalent rational numbers. So false. Here equivalent rational numbers of a positive rational number are all positive. Suppose let's take 1/2. This is a positive rational number. See, positive rational number, and let's write some equivalent rational numbers to 1/2. See, 2/4, 3/6, 4/8. These are equivalent rational numbers for 1/2. Here positive, 1/2 is positive and remaining all rational equivalent rational numbers are also positive. So this statement is true. With this we have completed our exercise 7. In fraction, decimals and rational numbers, what we have learned, we look once again. See, fractions, we have learned what are fractions, how to compare fractions and how to add, multiply, divide, subtract fractions. While coming to the decimals, we have studied what are decimals, how to represent decimals and how to add, multiply and divide and subtract the decimal. And while coming to the rational numbers, we have came to know what are rational numbers and what are equivalent rational numbers and how to represent them on number line, and we have also learned how to write the equivalent numbers. With this, our fraction, decimals and rational numbers chapter is closed. If you have any doubts, you can go back through previous videos and you can clarify your doubts. Thank you.